బయటకు బయట అయ్యో అది మొబైల్ దిగిట్ అవ్వండి ಒಬ್ಬರ ಇರುತ್ತಾ Okay. Everything is okay, I think. No. Happy New Year to all. Voice clear? There's some slight problem because this mobile has no charge. I forgot to charge it. I will start something. When I'm expiring, I'll put it for charging. I won't have any chat. Clear? Okay. I'll just put for charging. At least because that also not possible. No. Not possible. That pin it is not going. No use. It is absolutely no use. That pin is giving trouble. Then where to put it? ಎಲ್ಲ ಸುತ್ತಾಕೊಂಡ್ತಿತ್ತು ಈಗ. ಎಷ್ಟು ಮಿನಿಟ್? Okay, I can't do anything. Whatever charge is there, I will chat. If the charge goes off, hope nothing will happen. Okay, let it be there. See, start. Yesterday question, I told the question number, I don't know question number. Next question. Simply support beam of span 6 meter. Loaded, I already told. See, the question is what? Question is simply supported beam of span 6 meter. 6 meter. Loaded by UDL of, I remember, I noted down, 24 kilonewton per meter. I will call A and B. Center is C. They want to find theta max and Y max. This you can see now. Then in the question there is also find. That also find is extra. Remember, that also find is problem. This is extra portion. Usually unwanted, but still for knowledge purpose. See, first do one thing. Start. Sketch the real beam reaction VAVB. Tell me, if you want only theta max and Y max, you either require the full BMD or half BMD. do you require these reactions? Tell me. Reactions are there. Suppose you want theta max. See, it is this area. This area you are considering. For y max as this area. For reaction, full area. So, do you require the reaction to draw bending moment diagram? Tell me. Do you require reactions for drawing bending moment diagram when the beam is subjected to only UDL? Do you require reactions to calculation or not required? Tell me answer. To draw BMD, do you require reaction calculation or not required? You are not answering. This all I told last time. Do you require reaction calculation or not required? To draw the BMD so that we can use the full BMD or half BMD. See, there is no reply. If there is no reply, what to do? When questions are asked, if there is no reply, I can't take anything. Do you have to find the reactions? See, no answer, nothing. You told voice clear, that's all. Then further, no message, nothing. This much time you require to answer the question. Lag is only few seconds. What is happening? I don't know what is happening. See, even there is no response when the question is asked. Problem is what? I want to know that voice is clear. I do not want to take the full class. Later come to know that video is not, audio is not clear. I can't retake the class then. I asked a question which you know the answer, still not answering. Okay, what to do? If this way you respond, it is very difficult to take the class. Okay, I won't look at you. Reactions are not required because you know BM0, center BM is WL square by 8. I have shown the calculation here, see. I have shown the calculation. 0, 0, center, WL square by 8, 108, positive. So, plus 108, this is a BMD. Even if you find reaction, what do you have to do? Reaction into 3 minus 24 into 3 into 3 by 2, that only is WL square by 8. So, time being, reactions are not required. Okay, draw BMD. BM by EI diagram, conjugate beam. Find reactions. These all told yesterday. I won't repeat. I told you yesterday. Tomorrow when you come to the class, you finish theta max and y max and get ready for next part. Okay, then theta max is here, y max here. I will not explain. Why? Yesterday when I took span L, UDL W, that time when everything is explained, it is a numerical part. Therefore, that is your problem. Did you get this answer? Theta max and y max. Did you get the answer? Did you get the answer? That theta max and y max. Yesterday's question you have to refer, same way you have to solve. Yesterday W and L, today numerical. See, again no answer. You are telling reaction required. Conjugate beam required. I asked you, do you require these reactions? You are answering conjugate beam. Okay, leave it. Did you get this answer? For that also no reply. These two answers I gave yesterday. Did you get it? First of all, no need of explaining. Why? Yesterday it's already solved. WL square by 8 here, L by 2 here. Got it. Okay. If anybody new to the class today, suppose he mental I did not get it, go back to yesterday's class and come back. Not directly come whenever you want and study from me. Impossible. Okay. Now, I will remove all this. You make a neat fair copy of this one. Now tell me, also find what? What they want? Today's class is meant for this also find. Remember, I am solving this problem only for the purpose of that also find. Slope and deflection at P1 and P2. Tell me, where is P1? P1 is at, I think I noted down, 1.2 meter from left end, from A. And P2 is at, I forgot that one. Tell me, where is P2? I forgot that one. Where is P2? Okay, P1 is at 1.2 from left end. Where is P2? 1.6 meter from right end. Okay, that's all. 1.6 meter from right end. Okay, now right end, that is B. Now correctly observe. Today's class is meant for finding slope and deflection at an intermediate point. See, support slopes you already got yesterday. Central deflection you already got yesterday. There is nothing to tell for that one. You told, you got the answer. Okay, now this all I will remove. I will start today's class main purpose. See, even this reaction also I will remove. Unwanted. This is also not required. Okay. Everything removed. Later you do one thing. Those who have not come to yesterday's class, make a fair copy. How? By referring to yesterday's class, understand that one, then come to this class. Not directly come to any random class and tell, I want everything to be clear there. Everything will not be clear. It will come randomly to the class. My class always got continuation. Okay. Now, see, I will tell you next. Now, to find slope theta and deflection y at those 2 points, which points? P1 and P2. See, what I am doing? I am going to tell something now. What all I dictate, you should write. Remember, now what all I tell, you should write. First, go back to the system and mark the point P1 and P2. Actually, 2 points are there. Or any point. If they want only 1 point, mark that point without disturbing the main thing. This main marking, you should not disturb. P1 is at, see, this is 3 meter. 1.2 is here. Light line. Without disturbing P1. This is 1.2 meter. P2 is at somewhere here. P2 at 1.6 meter from there. Mark it. Okay, write it here. Then come down and mark the BM ordinate there. There is a BM ordinate here. There is a BM ordinate here. Okay, that ordinate. How much is not required for you? This is the BM at which point? P1, BM at P2. Further come down. In the conjugate beam also mark those points. Okay. See, without disturbing, see, here, this is your P1 point. Without disturbing, this is your P2 point. Or, instead of marking distance there, come down. Don't disturb anything. This is your point P1. This is your point P2. This is 1.2 meter. This is 1.6 meter. Okay, now the problem is what? See correctly. I will write statement. If you want slope here at P1 or P2, we want shear force at P1 and P2. What all I tell you should write. Or do one thing. First consider P1. If I want slope at P1, we need shear force at P1 in conjugate beam. Look this side. It is 216 minus this much load. Minus this much load. Oh, problem. Why? If you want load from A up to C, there is no problem. Why? A to C, this parabola from 0 up to center, area formula is there, 2/3 of base into height. But we want area of the parabola from here up to an intermediate interior point. From the end up to any interior point other than center. If we apply the formula, area equal to 2/3 base into height and CG distance at 3/8 or 5/8, it is utter nonsense. It is mathematical blunder. This all I told in which method? Tell me. This all I told in which method? Tell me. In which method? This all I told. First of all, which are wasting time. This all I told in which method? In which method I told all the same question I solved there. Moment area method. So those who got difficulty, go back to search this playlist, deflection of beam, go to simply support beam with UDL in moment area method, see what all I told, write it. Same thing right here. Therefore, we cannot use formula. When you cannot use formula, only alternative is integration. So what you do is, see now, what you do. You consider a point from between, see, we want to cover the area from A to P1, yes or no? And when I want P2, you look this side. I want to cover the area, see, I want this area. When I want slope and deflection here, I want shear force bending moment here. When I want slope and deflection here, I want shear force BM here. Here I will look this side, here I look this side. So here I want what is this area, what is this area. And also moment of that load about P1, moment of that load about P2 when you want deflection. So therefore in that region, see, somewhere here you take a point at X from here. Here also, somewhere here, take at X from here. So I'll do one thing. This side come later. Consider P1. Consider section at XX. Okay, section XX at X from A in AP1 portion. AP1. So section XX means that is here. See, somewhere here. Take a section XX at X from here. X only. Now, AP1. Find what is the bending moment there. Bending moment at that XX equal to, now you require reaction. So before that, right, since you are doing a via media calculation, now you require reaction. If you cannot find reaction, better leave the class, don't come back once again. Tell the answer. 24 kilonewton per meter for 6 meter. Symmetrical loading. Tell each reaction fast. Tell me each reaction. Anybody who is not able to get the reaction, better not attend any of my class in future. 72 kilonewton. If someone, he will tell, sir, that reaction is not clear. I will tell him, you better not come to any of my class in future. Okay, 72. So BM here equal to, see, 72 into X plus 72 into X minus 24 into, I will do one thing, 24 into X is the load into X by 2. I will put 24 X square by 2. Or those who want to understand, 24 into X is the load into X by 2. This is the BM. Now, when that is the BM there, you come down here. Same place, write what is the intensity here. This intensity. So you take a small strip here of thickness dx. Take a small strip here of thickness dx. Write what is the intensity there. Therefore, intensity of load for conjugate beam equal to whatever is BM divided by EI. How much? 72x. Or I can do one thing, 24x square by 2, I can make what? I can make 72x minus 12x square. 12x square. So 72x minus 12x square is the BM divided by EI is the intensity. Right here, if you want. This is 72x. Actually, writing is not required. Minus 12 into x square. Okay, x square. Now, write, that's all I require. Therefore, write what is area of elemental strip. Elemental strip in BM by EI diagram. In BM by EI diagram equal to whatever this ordinate. How much it is? It is 72x. It is 72x minus 12x square by EI into dx is area of this strip. This much clear? Is area of the strip. This much clear? Fast. This is clear? Area of the strip is 72x minus 12x square dx. Area. Now, suppose this area you integrate from 0 to 3. Will you get the same area you got by 2/3 base into height? Tell me. Suppose you integrate this area from 0 to 3. Will you get the same area which you get by the formula 2/3 base into height? Tell the answer. Suppose this is general formula. Suppose you integrate this one from 0 to 3. Will you get the same area which you got earlier by the formula 2/3 base into height? Tell me answer. Will you get or not? Suppose you integrate from 0 to 3. No, if you integrate from 0 to 3, will you get the same area? Yes, but don't do it. Why? If you want area from here to here, why you want integration? You got formula 2/3 base into height. Here formula is not there. Okay, that's all. This is for P1. Now, note, same for P2 also. Why? Same for P2 also, but remember, x from B. See, no? X from B. See here. At x, if I take x from here, Bm equal to 72 into x, symmetrical, minus what? 24 into x by 2. Everything same. So if you take a strip here, even for P2 also, at what distance? At, see, at x from this x from here, this is x, x you can see there only. At x from there, this thickness is dx. Thickness is dx. This also equal to what? 70, sorry, I forgot divide by EI here. Divide by EI, I forgot. EI. Same answer here. Where to write it now? No space. I write here. Even this also is what? 72x minus 12 into x square divided by EI, and area of this strip is same answer. This is valid for this strip also. Okay, start. Now, that's all you require. Start now. Now, consider the point P1. Consider the point P1. Okay, start. I want theta P1. How to find theta P1? Right. Theta P1 clockwise in real beam equal to shear force at P1 in conjugate beam. Left up is positive, right down positive, equal to slope here at the P1 equal to shear force here. Shear force here is what? Look this side. Plus 216 by EI plus 216 by EI minus what? Minus total load from A to P1. Correct? Minus total load on conjugate beam. Total load on conjugate beam from A to P1. Tell yes or no. See, shear force here. Here at P1 point, shear force equal to plus 216 minus total load from A to P1 in conjugate beam. Correct? Okay. Now, you know that for conjugate beam, load equal to area. You know it. Therefore, equal to 216 by EI. If you want total area from here to here, you know what is the elemental strip area. It is 72x minus 12 times x square is the what? X square. Okay, randomly. 12x square by EI dx is the area of a small strip. I want area from here to here. Tell me. Integrate minus. Integrate from 0 to how much? I want area from A up to P1. Hey, tell me. Integrate it from 0 to. Integrate it from 0 to. How much? Integrate from 0 to. Itottu beka? 0 to 1.2. 0 to 1.2. Now, tell the answer fast. Answer. 216 minus, first to calculate, 72 into 1.2 square by 2 minus 12 into 1.2 cube by 3. That answer subtract from 216. Answer. Fast. Take your calculator. First you do the integration. 72 into 1.2 square by 2 minus 12 into 1.2 cube by 6. Cube by 3. That answer subtract from 216. Big answer. 171.072 plus 171.072 by EI. Therefore, your theta P1 equal to 171.072 by EI radian clockwise. Tell me what answer I gave yesterday. Tell the answer. What answer I gave yesterday? What is the answer which I gave yesterday? Yesterday I gave the answer. What is the slope at P1? Yesterday I told. Tell, same. Okay, thank you. Thank you for having confidence. Okay, now this I will remove. Now I want deflection at P1. Okay, start. How much? Deflection at P1 in real beam equal to, in the downward direction equal to, bending moment at P1 sagging positive in conjugate beam equal to, see, bending moment at P1 plus 216 by EI into how much? 1.2 into 1.2 minus moment of area from A to P1. See, minus moment of what? Moment of total load from A to P1. Tell me about which point? I want bending moment at P1, about P1. But you know that load is nothing but area only. You know 1000 times. Area or equal to 216 by EI into 1.2 minus. See here. The strip area is 72x. 72x is the strip area minus 12x square area into dx by EI is strip area. Tell me, what is moment of the strip area about P1? Tell me, what is the moment of the strip area about P1? Distance of the strip area from P1. See, this is x, this is 1.2. What is the moment of the strip area about P1? That strip area into this distance. How much? Distance. What is the multiplying distance? No, what is the multiplying distance? 3/8 of 1.2. You cannot write 3/8 of 1.2. It becomes complete nonsense. I told you, 3/8 1/8 cannot be applied for partial area. That was I was shouting. You cannot apply 3/8 1/8 formula because that is the mathematical blunder. 1.2 minus x into what? Into 1.2 minus x. This is, right, you write here, this is moment of the strip area. But you want total area, integrate from 0 to 1.2 or equal to 216 by EI into 1.2 minus, this you can do one thing now, integration 0 to 1.2 of what? 72 into 1.2. I should do it now. Do you want me to struggle this way? Do you want me to struggle all these things? Okay. 72 into 1.2 is, okay. is 86.4x. It is 86.4x and then 72 into x minus 72 into x square, then minus 12 into 1.2. 12 into 1.2 is 14.4 x square. Lastly, 12 into 1 plus 12 into x cube dx. Now tell the answer. Calculate. See, 86.4 into 1.2 square by 2. 86.4 into 1.2 square by 2 minus, you can do one thing, 72x square and 14.4x square, you can combine together. This combined together will be equal to minus what? 72 and 14.4 combined together will be minus 86.4x square. Now calculate. 86.4 into 1.2 square by 2 minus 86.4 into 1.2 cube by 3 plus 12 into 1.2 power 4 by 4. That answer subtract from 216 into 1.2. Answer 216 into 1.2. Answer 240.5376. 240.5 plus 240.5376 by EI. Positive. Therefore, deflection at P1 equal to 240.5376 by EI radian, deflection, that much meter down. This will complete the point P1. Now, can you do P2 yourself only? Can you do P2? If you can do yourself only, I will briefly write it. If you can do P2 yourself only, answer already given yesterday. Answer already given yesterday. So, if you can do P2, why should I waste time? I will go to next part, important. We will continue for more important. Yes, okay. Now, briefly I will tell you. See, brief hint, not much. See here. When you go to P2, theta P2 in real beam, clockwise positive, equal to shear force at P2 in conjugate beam. Left up, right down positive equal to, see, look this side, minus 216 by EI plus this much load. That much load is this area. What is the area? 72x minus 12x square by EI dx. That one integrate from 0 to how much? 1.6. Get the answer. When you want deflection at P2 in real beam, downward positive, equal to BM at P2 in conjugate beam, sagging positive, equal to, see, here P2, 216 by EI into 1.6 plus 216 by EI into 1.6 minus moment of this much area. That is strip area first. What is strip area? 72x minus 12x square dx by EI is the strip area into moment about P2 is, this is 1.6, this is x into 1.6 minus x. Same as last time. Integrate it from 0 to 1.6. You get the answer. Answer already given yesterday. Can you complete and solve the question and get the value? Why waste time? Because in momentary also I told. Remember, this is only for those who want to learn more. If you do not want to learn more, you study only maximum slope and maximum deflection. Do not bother about such things. Okay, start. Over. Now, I will go to new part. Okay, now, before going further, see, there are two standard questions are there, which in moment area I have not done. It is better to do it in conjugate beam method, because tomorrow I am going for conjugate beam method for beam with eccentric point load. Remember, moment area method, we struggled. Draw a tangent here, take it there, draw a tangent there, take it here. That struggle is not there. It is very, very simple. But before that one, I will go for two standard book works. Sorry. Book work number 1, standard book work. A simply supported beam, see correctly, of span L is subjected to a couple M at one of the supports. Any support, I will take the support at A, any support, say this way. Sagging or hogging, no problem. If it is sagging, beam will deflect down. If it is hogging, beam will deflect up. That's the only change. Therefore, one standard case. Okay. Then, AB. I will give a numerical for you when the couple is at B after this question. Find theta max and y max. Also, theta max and y max, that's all. Very important. Also find deflection y at center. Tell me, those who are going for object, now I will do one thing now. See, before I start the question, I will give information. I will give information for competitive examinations. This is a very powerful question for competitive examination of slightly higher level. Suppose it is what rural water supply or this water supply, etc. Such question they don't ask. PWD or PGCET they may ask, but GATE or engineering service hall, it is a very powerful question. You should remember the answer. See, I will tell the answer because I know it. See, I know that you make a note. Later you check the answer. See, one note. When a simply supported beam is subjected to a couple at any one of the supports. I will not tell left support, right support. Formula is general. It is one of the supports. Then remember now, that means it can be either clockwise here, or it can be either anti-clockwise here, or it can be clockwise here, it can be anti-clockwise here. So any case, you never by heart left and right hand. Standard format is then slope, couple you call M. Okay. Span is L. Okay. Span is L. L is the span. Then slope at that support. Means which support? Where couple is applied. Where couple applied. Equal to ML by, tell the answer. If you know, those who came to my competitive examination class, I told very clearly by words, ML by number. And I will tell you one more thing, ML by number. If you know the number, tell the number. If you do not know, tell don't know. If you know, tell the number, or tell don't know. ML by. If you do not know, tell don't know. That's 2EI. Ayo, adu bere case adu. ML by 3EI. And this itself is maximum slope. And then slope at other support. That is, if the couple is at A, slope at B. If the couple is at B, slope at A is half of above value. How much, tell me? Half of above value. That is how much? ML by how much? Half of above value. That is ML by half of the above value. Where you apply couple, slope is ML by 3EI. Other support, lesser slope, it is half of this value, ML by number. It is ml by number 6 EI. 6 EI. Okay. ml by 6 EI. Okay. Now, one information for you based on this one. See, based on this one, L by 6 EI into 2 minus 1 minus 1 2 is derived. See, when couple M is 1, 2 by 6 is 3. See, formula is what? One of them is ml by 3 EI, other is ml by 6 EI. Again, if you apply couple there, here it is ml by 6 EI, here it is ml by 3 EI. You take m becomes 1 in the flexibility matrix method. When m becomes 1 in the matrix form, it becomes L by 6 EI into this will become 2. That will be 2, 1, 1, 2. Sometime plus, sometime minus based on sign convention. Remember, this is the flexibility matrix in matrix method. Have you heard it? In the matrix method, flexibility matrix, this is the flexibility matrix derivation. See, this is the derivation for flexibility matrix in the matrix method. Now, leave it now. Information. So, I told you which support you apply the couple, slope is ml by 3 EI. Other support ml by 6 EI. And then further, and deflection at center of the beam. Tell me answer. Anybody know it? It is ml square by what? Anybody know it? Deflection at center of the beam. ml square by, remember, it is 16 EI. Central deflection is ml square by 16 EI. And see, now the beam will bend. Suppose here, the beam will bend like this. Tell me, unsymmetrical. Maximum central deflection is what? Center deflection is ml square by 16 EI. And this is the Y maximum. Tell me, Y max will take place on which side? On Y max. If you apply couple at one end, Y max will come on that side where couple is applied or other side. Tell me, if I apply couple here, see, Y max will come. Common sense. When you apply couple here, where more bending? Couple side more bending or other side more bending? Which side more bending? Couple side more bending or other side more bending? See there, you take a beam and apply a couple here. Couple side more bending. So, maximum deflection will come near to couple, but distance is defined from the other end. So, maximum deflection for this one, and your Y max for this is ml square by 9 root 3 EI. It is slightly more than ml square by 16. See, ml square by 16 is what? 0.0625. Correct? Correct? ml square by 16 is 0.0625. I'll give all the information. 16 reciprocal. 16 reciprocal. ಏನಾಯ್ತು ಕ್ಯಾಲ್ಕುಲೇಟರ್ಗೆ 16 reciprocal ಇಲ್ಲಿದೆ reciprocal 0.0625, whereas 1 by 9 root 3 is 1 by 9 divided by root 3 is 0.6415, means slightly more. Or, and remember, this Y max will be at L by root 3 from that support where couple is not acting, or you can tell L by root 3 from the other support, because L by root 3 equal to 1 divided by root 3 is 0.577L. 577L is from other side, not center. It will slightly come this side, near the couple. See, if you mark from here, it should be less than 0.5. When you mark from there, it is more than 0.5. So, The formula is where you apply couple slope equal to ml by 3ei. That is the maximum slope. Other support slope equal to half of that value, ml by 6ei. Deflection at center equal to ml square by 16ei. And maximum deflection equal to ml square by 9 root 3ei. It will take place from center to that side where couple is there. So if you measure from other support, the distance will come more than L by 2. Clear? First, after the question is over, this statement I will not tell once again. I will tell, don't by heart A and B. See, it will fully become reverse. If the couple is here, everything will become reverse. Do not by heart A and B. Okay, now I will solve the question. Systematically, I will solve this one now and get the answer, because this is a standard case. You have to consider it, See, start. Question. 1 minute now. Let me see how much space is there. ಇಲ್ಲಪ್ಪ ಇನ್ನು ಬೋರ್ಡ್ ಓಡ್ತಾ ಇದ್ದ ನಾನು. Okay. Okay, no problem. Now, for solution, you consider a simply supported beam of span L, say AB, couple anywhere will do. I told in the class, clockwise couple at A, M. You can apply anti-clockwise also. One homework I will give you, when couple is at B, I will apply same clockwise, but this will sag, that will hog. Okay, start. Now, this is the given beam. Given beam. First, reaction calculation. Reaction, see, I will do one thing. This reaction, I will take VB. This reaction, I will take VA. Take moment. Sigma m about A equal to 0, take clockwise positive. Minus VB into L plus m equal to 0. So your VB equal to plus m by L. Sigma V equal to 0, take upward positive. Plus VA plus VB equal to 0, no load. We substitute for VB, VA will come minus m by L. Or you can tell, if you apply a clockwise couple m here, this reaction is upward of m by L. This is a downward reaction of m by L. Actually, I should not explain, because in the SFD BMD chapter, somewhere I told, when you apply a couple, how to find reaction, go and refer. I have given heading there. SFD BMD for couples. 3-4 classes are taken there. Class number maybe 93, 94 or 95 or 96. Fully explained. This much clear? First. Or I told you, one easy method there. See, you take the beam free. When there is only one couple, or when there is only couple, then couple is M. Both reactions are M by L. See, if you apply couple, one side will lift. Where lifting will come, to prevent it, reaction is down. See here, if I apply clockwise, left will lift. So left is down, right is up. Or these two will create a balance. This is a clockwise M. These two will create balancing anti-clockwise couple of M by L into L equal to M. Beam is in equilibrium. First of all, this much time I should not have wasted. Clear? Okay. Now start. Neatly put the real beam. Very neatly put the real beam. This is real beam. Real beam. I won't write real beam now. This reaction is M by L up. this reaction is M by L down. There is a clockwise couple M here. Over. This is A, this is B. Span is L. I write here, span is L. Okay. Now, draw BMD for real beam. Tell the answer. This is the BMD for real beam. Very important. Sagging positive. BM at B, 0. See now, I write somewhere here. BM at B equal to 0. After B, come to A. BM at A equal to, if you look that side, it is plus M by L into L equal to plus M. Or, that is, if you look right side. Or, if you look left side, you can see here only, it is plus M. Plus M. So, 0 here, M here. M. It is plus, very important. Joined by a straight line. Or 1 minute, this much not required. See, BM here, look this side, 0. BM here, look this side, plus M, over. This is the BMD for real beam. Now write BM by EI diagram. Okay. Same way write. This is your BM by EI diagram. How much here? M by EI. And one more important, if the BM is plus there, loading is downward. This I will not explain now. This I told thousands of times. Below, sketch the conjugate beam. Below, sketch the conjugate beam. Then, when the load is downward, there is upward reaction here, called VB dash. Upward reaction, called VA dash. Start. Calculation of reactions for conjugate beam. Remember, you cannot do like last time. What? Total load by 2. Tell why. You cannot write due to symmetry VA dash equal to VB dash equal to total load by 2. You cannot write. Why? Tell me. Why you cannot write? Like last time. VA dash equal to VB dash equal to total load by 2. That way you cannot write. Why? Why you cannot write? First, this charge is very lesser in this chat mobile. When the charge is over, I should stop the class. Why you cannot write? Why you cannot write VA dash equal to VB dash equal to total load by 2? Varying load. This is not symmetrical. No, varying load it is not symmetrical. Therefore, you use equilibrium equation. See, sigma m about A equal to 0. Take clockwise positive. Start. Minus VB dash into L. Minus VB dash into L. L is here. If you want to write, full span is L. Okay. VB dash into L plus moment of this load. How much? Plus half into L into M by EI is the total load. Half into L into M by EI for the total load. CG will be here. From here to here is 1 by 3 of L into 1 by 3 of L equal to 0. Therefore, your VB dash will come. This is minus. That will go other side. M into L into L. M into L into L is ML square. 1 L gone. ML by 3 into 2 is 6 EI. Okay. Now, sigma V0 take upward positive. Plus VA dash plus VB dash minus total load. How much? Half into L into M by EI equal to 0. You substitute for VB dash. Why should I waste the time? You calculate. VA dash will come ML by 3 EI. Substitute. ML by 2 EI minus ML by 6 EI is ML by 2 EI. Okay. Go back and enter. Enter the answer. Equal to ML by 6 EI, ML by 3 EI. Remember, calculated value. Okay. Now, reactions are over. Once reactions are over, start enjoying one by one in order. Start enjoying one by one in order. What they want? See, first, theta max. First, theta max. Theta max equal to either theta A or theta B, because your beam is expected to bend. How, tell me? This beam will bend. When you apply a couple M here, it will bend like this. That is guaranteed. So, undoubtedly, this slope will be more. That slope is lesser anyway, right? Now, theta A is not equal to theta B. See, to get theta A clockwise in real beam equal to shear force at A in conjugate beam, equal to slope here is shear force here plus ML by 3EI. ML by 3EI. Therefore, your theta A equal to ML by 3EI clockwise. To get theta B, because both theta I want, theta B clockwise in real beam equal to shear force at B in conjugate beam, left up, right down positive, equal to, come slightly inside, right up is negative, minus ML by 6EI. Therefore, theta B equal to ML by 6EI. I already told you, remember, anti-clockwise. Slope at the support where couple applied is ML by 3I. Slope at the support, other support, is ML by 6EI. Remember? I already told where couple applied, slope is ML by 3EI. Other support, half of that value, ML by 6EI. Yes or no? I already announced in the beginning only. Remember it? I announced in the beginning only. You forgot? Yes. Okay. Now you can, therefore, your theta max equal to ML by 3EI. Where? At A. At A means where couple is applied. Applied. Okay. This is over. Now do one thing. Find first one more important, deflection at center. Now, first I want deflection at center, standard. To get deflection at center. Why? It is very important for competitive examination. Say, name it as C. Come, now, go back and mark it. Mark C. Mark C and also mark whatever else required. Remember, center is not a standard point now, so I use red color, blue color. Sorry. Center is here. Center, see. From here to here is light line I'll put here. This is L by 2. Then this ordinate is, if this is M, why you want to waste time? M by 2. Or see here, M by L into L by 2 is M by 2. So this ordinate will be M by 2EI. M by 2EI. Why? Whatever is the BM here by EI is this ordinate. Without disturbing. See, this is your L by 2. Start. Deflection at center down in real beam equal to bending moment at center in conjugate beam sagging positive equal to, see here, plus ML by 6EI, ML by 6EI into L by 2 minus moment of only this much load, half into L by 2 into M by 2EI, half into L by 2 into M by 2EI is the total load into moment of this load about this point is 1/3 of L by 2 into 1/3 of L by 2 or equal to M into L is ML square by EI into 1 by 12 minus 1 by 2, 4, 4, 8, 8, 3, 24, 48. 1 by 48. Tell the answer. ml square by EI into number. 1 by 12 minus 1 by 48 number. 1 by 12 minus 1 by 48 number. Bega bega, time illa. 1 by 12 minus 1 by 48 number first. Because further the battery level has come down to 8 now. So another 10 minutes I cannot chat. 1 by 16. I hope I can finish Y maximum today. 1 by 16 plus 1 by 16 plus 1 by 16. Therefore, deflection at center equal to ml square by 16 EI down is the answer. Okay, now the important answer, that is maximum deflection. This is also over. Lastly, I write the result now for you. Okay, start. Lastly, I use red color. Maximum deflection. I told red color where I kept it. Partially red color. Okay. Lastly, maximum deflection. That is Y max. Make a note. If symmetry is there, Y max will be center. No, Y max will not be center. It will be somewhere this side or unknown point. So let Y max be at a point X, comma, at X from, now important. Shall I take X from A or X from B? Tell the answer. You should keep in mind calculation in conjugate beam. In the conjugate beam, if you take X from A, when you look that side, tell what you get. In the conjugate beam, if I take X from A, then what you get? Tell me. When you look that side, what loading you will get? In the conjugate beam, suppose I take X from here. When I look here in the conjugate beam, that side, what you will get? You should think of those things to save the time. Trapezium. Whereas, if I take X from B, what you will get? If I take X from B, other support, where BM is 0, where see, that BM is 0, triangle starts there. What do you get if you look this side? If you look right side, what do you get? Triangle. So what is better? Therefore, better take X from left end or right end, or X from B. Make a note. Always take X from that support where couple is not there, or where the BM ordinate is 0. Clear now? Make a note. Because if you take from here, trapezium will come. Always take X from that side where BM what is 0 there, so that triangle will come. Clear? Clear or not? That is important concept. Clear? Babe, tell fast. Battery level is very low. Charge is very low. If delay means suddenly if it goes, I can't chat then. I have to only explain and go. Class will not get over, but I cannot see your reply. See? You are not telling clear or not. Clear. Okay. Now, X from B. Do one thing. See, one thing sure. See, you can make out here. When the beam bend, when the couple is applied here, this is center. Beam will deflect like this. Y max will come here. See, this is the point X. This is center. It will go beyond center. Beyond center. This is your X. And this is your Y maximum. Or this is your Y at X, which is Y maximum. And at that point, theta X equal to 0. Remember all this one? Where deflection is maximum, slope equal to 0. Remember or not? Fast, fast. Do you remember or not? Okay, now start. Mark here. Now what all I tell right. Go back to the beam. Where it is maximum this side, without disturbing, mark the point X. At X from there. Then we want ordinate of the BM at that point. X from here. Here BM is 0. Here BM is M by L into L, M. Here BM is what? M by L into x. See, BM here. M by L into x or mx by L. If it is mx by L, corresponding ordinate at x here is what? Mx by L divided by EI. Why? Whatever is that ordinate divided by EI. And remember, without disturbing, this is x. Start. First, to locate x, to locate the point x, consider the principle. Consider what? Principle. What is the principle? Principle is where y is maximum, theta equal to 0, therefore theta x equal to 0. Now, theta x clockwise in real beam equal to shear force at x in conjugate beam. Left up, right down, positive. Slope here is shear force here. Right side up is negative. It is minus ml by 6ei plus half into x into mx by L into EI is the total load, this theta x. But theta x should be 0. Therefore, you get your m and m will cancel. You take other side, L, EI cancels. L by 6 equal to x square by 2L, or your x square will become 2L square by 6, or your x square will become what? L square by 3. Therefore, your x will become L by root 3. Clear or not? So, L by root 3 is x. Is clear? X will come L by root 3. Okay, now, last step. Okay, this I will remove now. Now, to get y maximum is y at x. Start. Y at x in real beam downward equal to bending moment at x in conjugate beam sagging positive. Bending moment here is ml by 6ei into x. It is plus ml by 6ei into x minus half into x into mx. I will put only x red color. Mx by LEI. See, this total load from here to here for this triangle, CG will be here, from here will be into 1/3 of x. 1/3 of x. Or if I substitute here now, it will become ml by 6ei into L by root 3 minus m by 6ei m by 6ei also into L into x is x cube, L by root 3 cube. Or this will be further equal to, you can push outside ml by 6ei, you can push ml by what? Or you can do one thing, okay, equal to ml by 6ei, if you ml square, why? L into L is L square, L cube by L is L square times 1 minus what? 1 minus 1 by 6 has gone outside. See, root 3 cube is 3 root 3. That 3 root 3 has gone outside by 3. Or, correct? Something 9 root 3 should come. Something happened there. ml by, okay, ml square by 6ei, also take root 3 outside. If you take root 3 outside, it is 1 minus, this all gone. L cube by L over. 1 by root 3 cube is what? 1 by 3 into root 3. So, root 3 has gone outside into 1 by 3. Simple mathematics. Or ml square by 6ei into root 3 into 2 by 3. Correct? 2 by 3. As 2 2s are, 2 3s are, 3 into 3 is 9 or equal to ml square by 9 root 3 is the answer. Therefore, answer, your maximum deflection is ml square by 9 root 3 ei at ei at L by root 3 from B. Or if you want to correctly understand, the final answer is, see now what all I told, I will enter once again. Do not by heart A, B, C, D or left and right hand. For a simply supported beam, you never, what all I tell right here, any support, you apply a couple M, beam will bend like this. Then, where you apply couple, their slope equal to ml by 3 ei. At the other support, slope equal to half of this value, ml by 6 ei. If you come to center, exact center, L by 2, the deflection is ml square by 16 ei. Whereas maximum deflection will cross the center, come near the support where couple is applied. From the other side, distance is L by root 3, and that maximum deflection is ml square by 9 root 3 ei. Remember, 1 by 16 is 0.0625. This is 0.064. Remember now? So this is more. Here, slope equal to 0. So never by heart left side, right side. Clear? Is the question clear? Now, battery level is so low, I think I will stop the class now. It is only 1 now. It will go off any time. Is the concept fully clear? Homework, tomorrow I will give you. Tomorrow I will take case of double couple. When a couple is at both ends, then the slope will become ml by 2 ei, then both slopes are equal, then deflection is ml square by 8 ei. Then I will go to tomorrow unsymmetric, eccentric point rule. Okay, thank you. I should go and charge fast because I have one more class. At least some charging required. Little, I forgot to charge.